Imagine flying a fighter jet at hundreds of kilometers per hour, then suddenly, the pilot pulls the aircraft upward. The jet turns violently. The world outside appears to move in an instant, but inside the cockpit, something far more dangerous is happening. The pilot's body is being pushed down with several times their normal body weight. This force is called G-force. At 1G, everything feels normal, but at 5G, a person can feel as if their body weighs 5 times more. At 9G, a pilot weighing 80 kilograms can effectively experience forces equivalent to hundreds of kilograms, and the human body was never designed to handle this for long. Blood begins moving away from the brain, vision starts disappearing, the world can turn gray, then everything can become completely black. A pilot can lose consciousness in only a few seconds, and at that moment, the most advanced fighter jet in the world can become uncontrollable. So how do fighter pilots survive forces that could make them unconscious? How do they train their bodies to withstand extreme acceleration? And what happens inside the human body when a fighter jet suddenly pulls? 10G tonight, we're going inside one of the most extreme environments a human being can experience, the cockpit of a modern fighter jet. To understand why G-force is so dangerous, we first need to understand what happens to the human body. During extreme acceleration, your heart is constantly pumping blood up toward your brain. Under normal conditions, this system works perfectly, but when a fighter jet suddenly accelerates upward, the situation changes. The blood inside your body has mass, and that mass resists sudden changes in motion. At high G, blood is pulled toward the lower parts of the body. Less blood reaches the brain, and that creates a serious problem. The first warning sign may be a change in vision. Colors begin disappearing, the edges of your vision become darker, then your vision can become completely gray. If the acceleration continues, everything can go black. The pilot may still be awake, but unable to see, and if the brain continues receiving too little blood, a pilot can lose consciousness. This condition is known as GLOCG, induced loss of consciousness. For a fighter pilot, it can be extremely dangerous because the aircraft doesn't stop when the pilot does. The jet continues flying at hundreds of kilometers per hour. That is why modern fighter aircraft and pilot equipment are designed together. The solution isn't simply making the pilot stronger, it's using technology to keep blood flowing where it matters most. And one of the most important inventions for this purpose is the G-suit. One of the pilot's most important pieces of equipment doesn't look like a weapon, it looks like clothing, but the G-suit can make the difference between staying conscious and losing control of an aircraft. The suit is designed with inflatable sections around the pilot's legs and abdomen. When extreme G-forces begin, the system responds. Air pressure increases inside the suit. The inflatable sections compress the pilot's lower body. This helps prevent too much blood from pooling in the legs. More blood can remain available for the upper body, and most importantly, the brain. Doesn't eliminate G-force, nothing can. Instead, it gives the pilot's body a better chance of surviving it. But equipment alone isn't enough. The pilot must also prepare their body before entering combat. Fighter pilots spend years training their muscles, their breathing, and their ability to recognize the warning signs of high G. They learn how to tense their muscles, how to control their breathing, and how to remain focused when their body is under enormous stress. Modern aircraft add another layer of protection. The cockpit seat is carefully designed. The pilot's position helps reduce the distance that blood has to travel to reach the brain. Every detail matters because at extreme G, even a few seconds can determine whether a pilot remains conscious or loses control. But pilots don't simply learn to tolerate G-force, they are trained to experience it safely before they ever face it in the sky. And that's where one of the most intimidating machines in aviation comes in, the human centrifuge. Inside a military training facility, there is a machine that looks almost nothing like an aircraft. A long mechanical arm extends from a central structure. At the end is a small cockpit. This is the human centrifuge. Its purpose is simple: recreate the forces a pilot experiences inside a fighter jet. The cockpit begins moving slowly at first, then the the speed increases, the pilot's body begins feeling heavier. 2G, 4G, 6G, the pressure continues rising. At high G, the pilot must perform a carefully trained breathing technique. Their muscles tighten, their abdomen contracts, their legs become rigid. Every movement requires concentration. Then, the centrifuge can simulate extreme combat conditions. The pilot experiences forces that would be dangerous without proper training, but the goal isn't simply to tolerate pain. The pilot must learn how their own body reacts. They learn to recognize the earliest signs of reduced blood flow, changes in vision, difficulty thinking, loss of strength, and the feeling that consciousness is disappearing. Training allows pilots to understand these warning signs before they encounter them during an actual flight. The centrifuge also shows an important truth: human beings have physical limits. Technology can push those limits, but it cannot completely remove them. That's why engineers don't just improve pilot equipment, they also redesign the aircraft itself to reduce the effects of extreme maneuvering. A fighter jet can perform maneuvers that would be impossible for an ordinary aircraft, can climb almost vertically, turn incredibly sharply, and change direction in only a few seconds. But how? The answer is aerodynamics. A fighter aircraft is designed around one goal: control. Its wings generate lift, its control surfaces change the direction of that lift, and its powerful engines provide the thrust needed to maintain speed. During aggressive maneuvers, when the pilot pulls back on the control stick, the aircraft changes its flight path, but the pilot's body doesn't instantly change direction. In exactly the same way, that difference creates the sensation of G-force. The faster the aircraft moves, and the tighter the turn, the greater the acceleration. This is why high-performance fighter jets can generate enormous G-loads during combat maneuvers. But there's a limit. Every aircraft has a maximum structural load. Push beyond that limit, and the aircraft itself can be damaged. That means fighter pilots must constantly balance three things: speed, maneuverability, and structural safety. A pilot may be capable of surviving a certain G-load, but the aircraft may have its own limits. Modern flight control computers help manage this problem. They constantly monitor the aircraft's condition and can prevent certain dangerous inputs. But technology doesn't change the laws of physics. At extreme acceleration, the pilot still feels every single G, and there is another factor that makes modern fighters even more demanding. Speed. G-force becomes even more dangerous when combined with speed. A modern fighter jet can travel at several times the speed of an ordinary aircraft, but during a tight maneuver, speed alone isn't the problem, it's how quickly the aircraft changes direction. Imagine traveling at hundreds of kilometers per hour, then suddenly the aircraft begins a violent turn. The jet changes direction, but your body wants to continue moving in its original direction. That resistance creates enormous acceleration, and the faster the aircraft enters the maneuver, the greater the potential G-load. This is why dogfighting is so physically demanding. The pilot isn't simply sitting inside a fast machine, they are constantly fighting against acceleration. Their muscles are working, their breathing must remain controlled, their vision must stay focused, and their brain must continue processing information at incredible speed. Meanwhile, the aircraft is turning, climbing, descending, and changing direction, all while the pilot may be experiencing several times their normal body weight. Modern helmet systems and high-performance flight controls help reduce the workload, but the human body still has to survive the forces, and that's why a pilot is considered one of the most important systems inside the aircraft, because the jet can be technologically advanced, but if the pilot loses consciousness, all that technology becomes almost useless. So engineers continue searching for new ways to protect pilots, and some of the most interesting solutions may come from the future. The fighter pilot of the future may not experience G-force the same way pilots do today. Engineers are already exploring new cockpit technologies. Advanced pressure suits could provide more precise protection. Artificial intelligence could help manage aircraft maneuvers. Flight control systems could automatically optimize the aircraft's movement before dangerous G-loads become excessive. Even the cockpit itself could evolve. Pilot seats may be redesigned to better protect the body. New materials could make aircraft stronger and lighter, and future aircraft may rely increasingly on unmanned systems. If there is no pilot on board, one major limitation disappears. The aircraft doesn't need to protect a human body. It can potentially perform maneuvers that would be impossible for a human pilot to survive, but human pilots are unlikely to disappear overnight. Human judgment, experience, and decision-making still remain incredibly valuable. The future may therefore combine both humans and intelligent machines working together. The pilot provides judgment and strategy. The aircraft provides speed, sensors, and precision, and artificial intelligence handles enormous amounts of information. But one thing will never change: physics. No matter how advanced the aircraft becomes, acceleration will always push against the human body, and understanding that force is essential to understanding the incredible world of fighter aviation. So, what happens when a fighter pilot pulls extreme G-force? The answer is far more complicated than simply feeling heavy. Blood begins moving away from the brain, vision can disappear, consciousness can be lost, and in only a few seconds, a pilot can become unable to control the aircraft. Yet modern aviation has found remarkable ways to fight back. G-suits protect the body's circulation. Special training teaches pilots how to respond. Centrifuges prepare them for extreme acceleration. Advanced aircraft use sophisticated flight controls to manage enormous forces, and every generation of fighter jets pushes the limits a little further. What looks like an effortless maneuver from the ground can be an extraordinary physical challenge. Inside the cockpit, the pilot isn't simply flying the aircraft, they are fighting against physics itself, and perhaps that's what makes fighter aviation so extraordinary. A machine traveling at incredible speed, controlled by a human being who must remain conscious while experiencing forces that can be several times their normal body weight. The future may bring smarter aircraft, better protection, and eventually more autonomous systems, but for now, the human pilot remains one of the most remarkable parts of the machine. If you enjoyed this documentary, don't forget to like, subscribe to Railforge for more documentaries about military technology, space, engineering, science, and the machines pushing the limits of human ability. Thanks for watching, and we'll see you in the next documentary.